Welcome to this explainer. Right now, we're looking at a massive paradigm shift in production artificial intelligence. We're going to unpack exactly how open-weight models have achieved performance parity, completely collapsed inference costs, and fundamentally shifted the competitive battlefield away from the models themselves and squarely onto the infrastructure layer. If you're building an AI right now, the ground beneath your feet is moving. Let's jump right in with a genuinely staggering number: 25 trillion. OpenRouter, the platform where developers route their real production traffic, is now processing 25 trillion tokens every single week. That is a five-fold increase in just 6 months. And the most critical piece of data behind that massive volume, the 5 highest volume models on the entire platform are all open. Which brings us to Section 1, the open weight takeover, and how open source is dominating production. So the biggest driver behind all that throughput is undeniably open-weight models. This absolutely proves that the open ecosystem is no longer just an experimental playground for hobbyists. It's officially become the default routing layer for real production workloads. What's really wild is how incredibly fast this adoption happened. Open-weight models went from a tiny sliver of usage to handling roughly 33% of all production tokens by late 2025. That's 1/3 of the global traffic. The market is just aggressively consolidating around open weights as the baseline. And the developer momentum backing this up is unbelievable. Hugging Face is now hosting 2.5 million public models, serving 13 million users. Because of this massive level of accessibility, a third of the Fortune 500 are now operating directly on these open registries. They're actively choosing data sovereignty and cost control over being locked into a single vendor. Moving on to Section 2, the vanishing capability gap and catching up to the giants. You might be wondering, why is this enterprise adoption happening at lightning speed? Well, it's because the performance delta, the quality difference between independent open models and the massive closed lab models, has effectively vanished. The absolutely crucial number to remember here is 0.5%. Back in early 2025, the capability gap between open and closed models was around 3.3%. Today, that gap has collapsed to just 0.5%. Production pipelines simply no longer have to pay a massive premium for closed models just to match baseline reasoning. To really put that into perspective, the open-weight DeepSeek R1 model is actually outperforming OpenAI's O1 Mini on some incredibly rigorous math and reasoning tests. On the AIME 2024 benchmark, DeepSeek R1 scores 79.8% compared to O1 Mini's 63.6%. And what's truly revolutionary about that is DeepSeek achieved it purely through large-scale reinforcement learning, completely skipping the traditional supervised fine-tuning step. But it doesn't even stop with massive models. Through a process called distillation, DeepSeek proved that you can literally transfer these high-end reasoning capabilities into much smaller, highly efficient, dense models, like those in the Qwen and Llama families. This means you get top-tier reasoning in a tiny footprint, making them incredibly powerful, yet incredibly cheap to run locally, on the edge, or even in totally air-gapped enterprise environments. This leads us right into Section 3, the cost collapse, where intelligence approaches zero. Let's do a quick economic reality check. As capabilities match up across the board, pricing pressure is just accelerating wildly. Intelligence is fundamentally approaching zero cost. Over just a 36-month period, inference costs for GPT-4 class capabilities have plummeted from $20 down to a mere 40 cents per million tokens. That is a completely unprecedented drop in the cost of compute and reasoning. And that massive drop is exactly why the Epoch AI 2025 Index documents a 9x to 900x annual decay curve in model performance differentiation. So what does that actually mean for you? It means today's state-of-the-art model is quite literally tomorrow's baseline commodity. To maintain parity, you have to iterate rapidly because the actual weights of the model are losing their unique value almost overnight. So that brings us to a massive paradigm pivot. Honestly, probably the most important takeaway of this whole explainer. If the weights, the models themselves, are becoming these cheap, swappable, essentially free commodities, who actually holds the leverage in AI today? Where's the real competitive advantage? The answer is in Section 4, the new infrastructure battlefield, and moving up the stack. The competitive battlefield has completely shifted away from the models entirely and moved up the stack. The real value now sits in the infrastructure, the serving engines, and the orchestration layers holding these systems together. At the enterprise scale, leverage belongs to production serving engines like VLLM. Originally developed at UC Berkeley, VLMM optimizes memory through paged attention and handles continuous batching. This lets enterprises serve hundreds of concurrent users at maximum throughput, regardless of whether they swap a Llama, a Qwen, or a DeepSeek model into their backend. Now, for local, on-device, or edge deployments, developers are absolutely flocking to dead-simple tools like Ollama or container-centric runners like Ramalama. It's a real game-changer because you can securely deploy small language models locally without ever needing an API key. This is absolutely critical for highly regulated sectors like banking or telecom that demand absolute data sovereignty and air-gapped execution. And then we have the orchestration loops, tools like LangGraph, Crew AI, AutoGen, and Llama Index. This is where raw language models are transformed into autonomous agents. The reason and act cycles managed by these tools are the new true source of application value. They handle the memory, the planning, and the actual tool calling that gets real work done. Which brings us to our final part, Section 5, the 2026 Developer Playbook, Architecting for the New World. So what do you actually do with all this information? If the models are basically free and infrastructure is king, here is your urgent developer playbook. First, you absolutely must pin your model versions in your manifests. Relying on latest tags introduces massive cache and validation risks. Second, get the Model Context Protocol, or MCP, and agent-to-agent connectors implemented immediately so your agents can communicate across platforms. And third, rigorously audit and apply strict read and write permission scopes at the harness level. Because the reality is, the risk isn't about model capability anymore. It's about orchestration overhead and unbounded agent actions. When token costs hit near zero, the real danger to your production environment isn't a model giving a bad answer. The real danger is an unconstrained agent executing unauthorized actions at lightning speed just because you didn't lock down the permissions in your orchestration layer. I'll leave you with this final provocative thought for our explainer today. In a world where the intelligence layer is effectively free and models are rapidly decaying commodities, are you actually building real infrastructure leverage through secure data orchestration? Or are you just renting swappable weights? Focus on your infrastructure, secure your agent loops, and own your deployments. Thanks for joining me, and keep building.